Hello students, welcome back to our discussion of Chapter 8, Hypothesis Testing. We just went through the 6-step process and we have concluded we have sufficient evidence to reject the null hypotheses. Basically that means, this statement here, to reject the null hypotheses, means that we can do this to the null hypotheses. We can cross this out, which leaves us the alternate hypotheses, which basically means that the average is not 8 centimeters. We don't know at this point what the average is for McDonald's French fries, but we do know that it is not 8 centimeters. Let's go back to our PowerPoint. We can go over as a little review, I should say. We have identified the company statement, the null hypotheses. We have identified the testing statement, the alternate hypotheses. For McDonald's case, this was a two-tailed test. We found the critical value. We calculated the test statistic, and we made a decision to reject the null hypotheses. I just want to emphasize here again that you have two choices. Choice 1, to reject the null hypotheses based on this decision rule. Reject if the test statistic Z is greater than the critical value. So remember, when you're using this rule, to change both values to positive, that way we only need to have one decision rule. So once again, your two choices: to reject the null hypotheses, or the opposite is to not reject the null hypotheses. No other statements are valid. Neither statement or both statements refer to the null hypotheses. So we will never say to reject the alternate hypotheses, or to accept the alternate hypotheses, or even to accept the null hypotheses. These are the only two statements you can make as part of hypothesis testing: to reject or do not reject. Let's go on to some other examples. First of all, let's go back to this question here. And in your lab assignment, you have basically this type of question. The only difference in your lab assignment is that the sample standard deviation the population standard deviation is not known. So then you have to use a sample standard deviation. So in your lab work, everything would stay the same, except for your critical value is going to be a t-value. Your test statistic is going to use the t formula, and then you are comparing two t-values. So let's go and do that sample question. This is an example on page 103. I have it written here. Right there, the population mean income in the city of Red Deer is assumed to be 70,000. A sample of 25 people has a mean of 65,000 and a standard deviation of 10,000. Test the claim that the mean is different than 70,000 at the 5% level of significance. So let's go through this 6-step process. Let's change that to let's do red. Red stands out here. The null hypotheses. This is a question dealing with the average. The average income in the city of Red Deer is assumed to be 70,000. So basically that is implying that the average is equal to 70,000. We can look at the alternate hypotheses, and that's stated as well at the bottom. Test the claim that the average is different, not equal to 70,000. The value on the right side of the equality sign, in this case 70,000, they're going to be the same for the null and alternate hypotheses. So can you tell if this test is a one-tailed test or two-tailed test? Right, you should be able to say that this is a two-tailed test because of the equality sign in the null hypotheses. Keyword here is different, so that once again implies a two-tailed test. So that's step 1, that's step 2, step 3. Step 4 is to find the critical value. Critical value is going to be a Z value or a T value. So let's go Z alpha or T alpha. Which one is it? Well, it depends on the standard deviation. If the population standard deviation is given to us, then it's Z. If not, it's a T value. So in this sentence right here, we have a sample standard deviation, or we have the statement about the sample. A sample of 25 people has a mean of 65,000 and a standard deviation of 10,000. So everything in this sentence here is dealing with the sample data. So this is what we have. We have the sample data, or the sample standard deviation equals 10,000. The question does not give us the population standard deviation. So I'm just going to write that up here. This is not known. Therefore, we have to calculate sample standard deviation from our data. And if we don't know the population standard deviation, we use the sample standard deviation, and then we use a T value. So we need to find the critical value, which is a T value, which is going to be based on alpha and degrees of freedom, which always equals n-1 for hypothesis testing. So let's go to our t-table. We have this. Let's make this a little smaller. Let's keep it right there. Let's just bring it out a bit. Look at the mess I made. There we go. So alpha is 5% and sample size is 25. Okay, I'm going to write this in blue. Let's see if I can quickly erase some of this stuff. Never likes how I erase. I don't want to clear the canvas. Okay, so this is what we know for the other example. We know that alpha is 5%. We know that it's two-tailed. Therefore, half of alpha is 0.025 and degrees of freedom equals 24. Sample size n is 25, so 25 minus 1 gives us that value of 24. So this is what we need in our example. So we're looking at this column again, and we're looking at 24 degrees of freedom, which gives us this value right here, 2.064. 2.064 is the value we find for our critical value. So T alpha, even though we divided by 2, we'll just use T alpha as the notation for our critical value. It's going to be plus and minus. So basically this is showing us that the critical value is our threshold value. The average is assumed to be 70,000. And we have a critical value here. If it's well above this threshold value, if our sample data is somewhere in this red area here or somewhere down here, if it's a lot lower, or a lot higher, we would have enough evidence to say that the average income is not $70,000. So step 5 is to calculate the test statistic, which is based on the sample average minus population mean divided by the sample standard deviation over the square root of n. So now we put in all these values. The sample average is 65,000 minus 70,000. Sample standard deviation is 10,000 divided by the square root of 25. This is going to be a negative value. And refer to my calculations. 70,000, 65. I get a t-value of negative 2.5. This value of negative 2.5 is going to be right about there. There is our test statistic, negative 2.5. Clearly in that red area can be referred to as, let's just put it up here, a rejection region. I think in the course notes I have, that's what it is referred to. So let's just bring that up as well. So in a two-tailed test, there is a rejection region on both ends of the distribution. We are clearly in that red area. So we are clearly going to reject the null hypotheses. We can bring in our decision rule to see that we would also reject the null hypotheses. Remember, our decision rule is to reject the null hypotheses if the test statistic, in this case it's the t-value, is greater than the critical value. The test statistic is 2.5, which is greater than 2.064. So therefore we will reject the null hypotheses. Which means that we can go back here to the first step we did. We are rejecting a null hypothesis, so we can cross this out, which we're left with this statement, which tells us that the average income in the city of Red Deer is not 70,000. We don't know what exactly it is. We would have an idea that perhaps it's less than 70,000, but statistically we would be able to show with significance that the average is not 70,000. So this is an example we've just done. Let's stop this video here. We'll come back to this slide in the next video.